Okay, so yeah, it's my honor to welcome Shankar MARUWADA, who is the founder of EkStep Foundation in India. So I'll just give you a brief introduction to Shankar's bio. It'll just be brief. There's some information on the TCLT website and also on the EkStep Foundation website. Shankar is co-founder and CEO of EkStep Foundation, as I said, a non-for-profit foundation which has enhanced access to learning opportunities for 200 million children across India. So as you know, India is essentially known as a subcontinent and has approximately 1.2, 1.3 billion population. I hope I'm close to that number, Shankar. The foundation has developed a set of configurable, extendable, modular building blocks under the Sunbird umbrella, which are designed for population scale problem solving, such as a country like in India, and are free to use and open sourced under MIT license. And Sunbird has been recognized as a digital public good by the Digital Public Goods Alliance in India. Shankar is deeply passionate about data research and leveraging technology for large-scale transformation in society. And I will stop there and I'll hand over to Shankar, who's going to give us a keynote talk this morning on resolving the technology paradox in education.
Thank you. Thank you, Phil. If I may share my screen.
Yes, please.
Thank you.
Yeah, you can now.
Okay. So a very good morning to the chair of the session, Dr. Philip Benashore, esteemed members of IEEE, and the august audience gathered today. I'm honored to speak and share experiences from India on the usage of technology in education. As most of you know, India is big, complex, and diverse, but school education in India especially so. The number of children studying in schools is more than that of Europe and North America combined. And the complexity of language, we have 20+ official languages of instruction, but hundreds of languages and dialect. In fact, the language is likely to change every 50 kilometers one travels in India. And each of the 60 boards of education have their own autonomy to decide the what and the how of children's education, the curriculum, pedagogy, and therefore the usage of technology in education. If there was ever a situation tailor-made for a technology intervention in education, we thought this was it. And that is how we started EkStep Foundation in 2015, along with my co-founders Nandan Nilekani and Rohini Nilekani, who are two of India's biggest philanthropy donors. And so for the first 2 years, we naturally tried to solve everything using technology. We experimented and tried every possible edtech inspired by the latest and greatest from all around the world, industry, academia, not-for-profits. Personalized learning, AR/VR devices, gamified learning, free-to-use apps and platforms. And that's when we encountered the technology paradox, which is technology works beautifully in small pilots at a small scale, but at a scale and complexity and diversity of any nation, large nation, forget India, we could not come across any edtech that scaled that much and that was sustainable, that was systemic. But that was 5 years ago. Today, this is where we are. 50 billion plus minutes of learning, over 4.1 billion learning sessions, 200,000 plus pieces of content in 33 languages, including the Indian Sign Language, and including some dialects which do not even have a written script. Thousands of packaged courses which have been consumed and have generated 100 million plus verifiable teacher training credentials. I'll talk more of some of these, and 600 million textbooks which have QR codes in them, which I'll talk about shortly, have been printed and distributed. However, the journey from our initial euphoria to now, over the past 5 years, was neither easy nor linear. In fact, it was during our early experimentation with technology, and we always do intensive consumer research when deploying any technology. This is not just research to figure out how consumers use it and whether they like it or not, but going into their psyche. What are they thinking? What are they feeling? What emotions are coming up? And in one such research, the mother of an 8-year-old boy told all the technology that she saw on display, saying, "Sir, all of this is wonderful. It will keep my child engaged, but this is just the icing on the cake. This cannot be an everyday affair." And then we probe further. And then that's when we had an epiphany. And then we went back to all our research and all the learnings from around the world. And we realized that the importance of parents in school education, the importance of trust in school education, the importance of accountability in school education, and therefore the role and therefore distribution of any solution, technology or otherwise, cannot come unless parents are convinced, the system is convinced, and therefore one can leverage the trust and the accountability of the system. And that epiphany allowed us to pivot, and we made two crucial decisions. One, that we will work with those who already have the trust, with those who have the distribution. And second, we will have to rethink about how technology has to be used to blend in to the existing systems and habits and rituals. And from that epiphany around 5.5 years ago, we now have national adoption and usage. And so the way of using technology, we decided, had to be a system of solutions approach. And we co-created the system of solutions by working with a large ecosystem of government actors, central and state, not-for-profit organizations, and for-profit organizations included. And this system of solutions, and I'll go into some of these examples in greater detail shortly. The system of the solutions was deployed through Diksha. Diksha was a Government of India platform that was made available to the entire country. And this whole program was implemented through India's existing federated decentralized structures of education. So to clarify, Diksha was the program and the platform of the Government of India. So as the owners, they're providing the budgets, they're creating coordination mechanisms, and they designated an academic body, the NCRT, as the program owner. And there was a program management unit under a steering committee, and EkStep was part of the steering committee and the project management unit. And this steering committee worked with the 35 plus states and central organizations and with the respective state budgets and teams. So therefore, the states were using the Diksha platform for their own purposes. In other words, Diksha right from the beginning was thought of as a national infrastructure available for the whole country. I talked of a system of solutions. I will now illustrate 4 or 5 of these solutions in the following slides. The first breakthrough for Diksha was energized textbooks. What we realized was our initial thinking was to solve for what does not exist, to solve for scarcity. But then we asked ourselves, why don't we leverage what is already abundant? And what we realized was in India, the humble textbook is ubiquitous because the government provides free textbooks to everybody. And because of the Indian culture, books, especially textbooks, are very highly respected. And therefore, any content in a textbook is highly trusted. And therefore, if the textbook can become the equivalent of a digital distribution device, and if a unique number QR code can be added in various pages, which when clicked points to relevant because it's relevant to that particular page. In this case, it is, when you click on this, it opens up a video of this children singing as a kind of interactive content. So it brings to life the textbook. It's a window to a digital world through a trusted source. However, it was neither EkStep nor the government of India that created the 200,000 pieces of content in the 33 languages. Each state which had voluntarily come on board added these QR codes into the textbooks that they published at places they wanted, against topic they wanted, and then they created digital content relevant to that. And this was a very strong winner. Within a matter of 3 years, we went from 2 states adopting it to pretty much 35 plus out of the 38 states and union territories adopting this. And it was voluntary. There was no mandate from the center. And states would come when they wanted, how they wanted onto the platform. The other thing was, part of Diksha was that every click, every interaction of every user is captured as data available to the accountable authorities. So in this case, every click of every user from every device is captured as a click stream, but this is the data of what is the usage and not who the user is. So the states don't know who's using it by design, but they know what kind of content is used, for how long, what time of day, etc. And because the structure was deliberately designed for a massive federated system, every state could design the language, including some of the boards that created content in the Indian Sign Language. And the dissemination or the consumption of this could be through multiple modes. If device, then online or offline. It could also be television or radios. It could be used in classrooms or beyond. However, the biggest thing about this technology that I would like to leave behind is what we realized, that the best technology is that which is invisible. In this case, 3 familiar technologies came together. The textbook, the QR code, which became popular in India because of digital payments, and the ability to take a photograph on a mobile phone, which was common. Three familiar technologies came together to create a mind-opening experience, after which nobody could see a textbook without a QR code. And over the succeeding years, the number of grades, states, content with QR code just exploded. That's why these are called as energized textbooks. You have energized the existing textbooks by adding a QR code. Moving on to the second use case, during pandemic, schools were shut for more than a year in India, but schooling continued. Therefore, the energized textbooks I explained earlier came in handy. Teacher training, which had also stopped, could now switch to online modes, because in India, most teachers have a device of some sort. Almost all teachers have a device of some sort. It could be a phone or a laptop. And again, here, the federated model of training came in handy, where a set of 18 modules were created. Now the states could take that, modify it for their context in their language. And this allowed a program which would otherwise have taken a full year to be completed at 4 times the speed and at 5% of the cost. And unlike an offline, the governments had very precise data on what kind of content was being used how. And it also allowed each of the states to issue a digitally verifiable certificate, which looked pretty much like a physical one, but this was verifiable. And we had many instances of teachers proudly sharing these digital certificates with their friends and family, and also taking printouts of it and hanging it in their walls. So from teacher training, then we evolved to micro learning packages, which are short form, always available, geared for specific occasions like exam preparation, learning loss during COVID management. This could be very short packages of 10 minutes, 15 minutes to explain one concept with some illustrated videos, some questions, some practice questions, and a quiz. And each of the states could create their micro learning packages. This has been launched just recently, less than 6 months ago. And already we're seeing a lot of usage of this, because this also allows teachers to see the level of learning of their children. What kind of learning packages are they consuming more? So this is again something which is very exciting. And the way each of this has been created is the technology is context neutral. So whether you use the micro learning package for school education in India, or for training nurses in the UK, or for training emergency services in Venezuela, the same technology can be used and layers can be added on top to contextualize it. Moving on, at the scale of India, it is not very easy to see the learning levels of millions of children very quickly. By the time, and the current method is only through the annual examinations, and that's at a very high level. So in co-creating or in understanding some of these problems, what we realized is the inability of boards to see just in time the learning levels of the children, so that remediation could be done. So by studying some of the existing practices in some of the states where they would grade the children, then enter the marks manually onto Excel sheets. Those would be uploaded by some IT administrator. They would inevitably be riddled with errors or incompleteness, and the state would see this after 6 months. So what we did was, working with a state, we modified the marks entry paper so that through an artificial intelligence algorithm, the handwritten numbers like here could be decoded, or here could be decoded. And that could now be scanned with an app with the teacher's phone, which suddenly gave very, very granular data of children, which could be aggregated at a school level, a cluster of schools, an administrative block, or finally the state. And each unit of administration gets the data at the level of granularity they need. So state does not need to see the data of an individual child, but a teacher needs to. So what this started revealing was patterns, which learning outcome is the entire state's children weak in, which are the weaker districts, and what learning outcomes are they good at or worse at, and therefore what can be done about it. In fact, an interesting anecdote from Assam is one of the poorly performing states was doing very well on one particular learning application, which was usage of maths in day-to-day lives. Now, we could not figure out what that was and why that was, but the state officials, when they saw it, they said, we know why. Because this state is so poor that the children are used to sitting in their parents' shop or helping their parents with work. And as part of that, they have to handle money. And you've seen children handling money with dexterity. So that could be an explanation. So they checked with that particular block and they said, yeah, that could be the reason. But nobody was aware, right? And this set them thinking that we need a block by block strategy, not even a statewide strategy to begin with. Seeing the success of one state, the other state took, but they modified the format because each state conducts exams in a different way. And each state had different priorities. Some wanted to focus on a baseline endline assessment. Some wanted to focus on weekly formative assessments. Some wanted the format in a certain way. But they all learned from each other and built off each other. And the last I'll talk about is visible micro improvement projects for bottom-up innovation. This is where an individual teacher or a school principal can set up a project, let's say a reading campaign as a project, start the project, list out the tasks and say that I've completed the following, and these are the results that I've had. And another teacher could be inspired by this and create their own project. And therefore the administration gets a sense of what are the kind of projects that teachers are doing and give a sense of some bottom-up innovation. That somehow this reading campaign seems to be a set of projects that teachers are learning from each other and implementing. And therefore, can we do something systemically? So the ability to create a project, it's not sophisticated technology, but creating it in a way that it blends into the teacher's habits and the system's habits was what took us the better part of 1 year to design. But already in the last 6 months, around 40,000 such projects have been initiated and 30,000 have been completed. And the respective state knows what area of which state and for what project are they creating these projects on Diksha. So I've given you a flavor of the systems of solution idea. This was enabled through a building blocks approach, which essentially provides micro capabilities at a mega scale. These building blocks can be combined and recombined to design solutions for a diverse set of complex use cases. And in doing so, they can become digital public goods powering diverse solutions, like Sunbird became, or in fact, even Diksha itself has been designated as a digital public good by the government of India, which means any other country can go to GitHub and take the whole source code or take parts of it and then build on top of that. I will spend some time on a building block approach. A brick is a building block. It's a part of a construction. There's very, very specified capabilities, but you can use it to construct a church or a house or a gambling den. Building blocks can be combined or connected. But most importantly, the value of a building block increases when it's combined or connected. So if you take digital building blocks, and a GPS is a very good example, they are autonomous. They can work independently of others like a GPS, and they provide very generic capabilities. All a GPS provides is latitude, longitude, and some other information like time, etc. And GPS, as we know, works with a whole lot of other technologies, interoperable. And if you create a solution with GPS, as the GPS technologies evolves, or the camera, and there's another building block in a cell phone, as a camera evolves, the whole mobile phone need not be recreated. Evolvability is a very important aspect of a digital building block. And if I were to use the analogy of a tangram, the building block design approach starts with a universe of solutions and then breaks them down into the fundamental elements that constitute the solutions. These elements can then be standardized as digital building blocks, enabling a larger ecosystem to use these blocks to create solutions for diverse contexts. And these solutions work at scale. It's not a new idea, it's a very old idea, because as a human population, this is how we solved the problems of construction and transportation and many, many other large-scale problems. These have been built in layers. And so Sunbird, which is what EkStep initially created, but now there is a community around it, is a set of building blocks that powers multiple population use cases. These are some samples of the types of building blocks. And the website sunbird.org has much more examples and details. So each building block is open, modular, extendable, and configurable. And there are 4 types of building blocks. There could be just specifications or protocols, software code, platform, or application. And what you realize is as you go from specification to application, it is becoming more context intensive. Specification can be context unaware, independent, but an application, the final solution has to be very, very context specific. And these building blocks of Sunbird power a range of solutions, not just in education, but in India. While Diksha was the first platform created using Sunbird, CoWIN, a platform around COVID vaccination, used a part of Sunbird, and therefore the same technology that was used to generate 100 million digital credentials for teachers has now generated close to 2 billion vaccination digital certificates for the population. Likewise, ICALT is a program of another department of the government of India for training civil servants. And Uday is a program of a state for training its population in fintech literacy. And there are many more. Sri Lanka has taken some of these building blocks. Bangladesh has taken for usage in judiciary. And many other countries are looking at leveraging these building blocks. Of course, the success of a building blocks approach needs an ecosystem. So in the case of India, Sunbird powered Diksha, where itself a whole bunch of actors came together. But it also was an ingredient in CoWIN, where again, an entirely new set of actors had to come together. And each of these platforms, Diksha and CoWIN themselves, are digital public goods. So other countries can take it, or they can just take certain parts of Sunbird, whatever they want, and create entirely new solutions based on that. The technology is open, free to use, interoperable, and it works reliably at population scale. And most importantly, it is evolvable. Here are some examples. And to give you a scale benchmarking, and with reference to some of the for-profit giants. So for example, the knowledge model uses Neo4j right now, which can graph 2.5 million objects and 40 million relations. To give you a sense, Walmart can graph 1.6 billion. In terms of data pipeline, currently 2 billion messages a day is the capacity, whereas LinkedIn is 500 times that, a trillion messages per day. So the technologies used are the ones chosen by these giants because that's the scale that India needs. And remember, it's just the early days of Diksha. As Diksha gets more and more scale and usage and more diverse applications, these numbers will shoot up dramatically in the coming years. In terms of specific technology stacks, this is the range of the specific technology used. The only consideration is every component has to be open sourced. And therefore, when any institution or country takes this, there is no dependency on just Sunbird or EkStep or the government of India. And this aspect of digital sovereignty is very, very important in our design. And also the fact that therefore, the data that is available of the users is available only to the owners of that platform and obviously not to Sunbird. However, technology cannot work in isolation. In education, many other elements have to come together, as we know. Not just the internet connectivity, devices, and the obvious content, but taxonomy, curriculum, what should be the learning outcomes that we want, and of course, school infrastructure. If a country does not even have schools or devices in the school or any kind of connectivity, then a lot of this will not work, or it has to be modified to make it work there. In summary, the way we overcame the technology paradox was by realizing that technology is just one ingredient in the solution. It's never the silver bullet. It's always a lot of things around it that come together to create a solution. It can be a very good force multiplier, but if there is no force, there is nothing to multiply. So technology is just one ingredient. The second thing that we learned was the design and the deployment of technology has to be +1 to the system. What I mean by +1 is strangely familiar, yet mind-opening. As I explained with the idea of the energized textbooks, or the idea of scanning a physical mark sheet and then editing it if needed to get instantly marks of everybody in one shot. The systems, habits, rituals, infrastructure, day-to-day routines have to be such that technology has to blend into it. If not, we will always have technology that works well in the lab, but will fail in the wild. Third, in designing, one has to think of what will work at the scale. We have seen a lot of attempts, including by us, of making something work, getting the satisfaction of seeing it work, and then realizing that, oh, but this will not scale up. So to think population scale, one has to think about what will work at that scale. And what will work at that scale cannot be a +10, where you're expecting the system to undergo dramatic change. Instead of a +10, we realize that it has to be a cleverly designed sequence of +1s, such that each change, each +1 is irreversible. And that was another learning for us on what works at scale. And therefore, in designing what works at scale, we found a building blocks approach useful. And we realized that in hindsight, it was common sense. It was right under our noses all along. That is how we design large scale systems. What the building blocks did was it allowed us to work with the existing institutional structures and systems. It allowed us to solve for the technology divide and convert it into a technology dividend. It allowed us to leverage what was already there, textbooks and teachers and school infrastructure. And it allowed us to rapidly reconfigure solutions through trial and error so that those solutions are +1. But as I personally reflected on it, this is the nature of technology. It is iterative. It is combination of building blocks. It is just a question of asking what would work in the context of India. Because EkStep started by saying that we want to reach 200 million children. If we had set a goal of 1 million children, we would have succeeded. But even with our initial experiments with EdTech, where we had solutions that would reach 2 million, 20 million, which is a lot, we realized it is still a fraction of the whole country. So we had to abandon that and then restart. And these 4 things allowed us to overcome the technology paradox in education. Things are still work in progress. We are still learning a lot every day. But I would like to conclude this talk and state that the journey is not yet over. We've reached some very important milestones, which is the reason why we called ourselves EkStep in the first place, because Ek is one in Hindi. And like the old Chinese proverb, a journey of 1,000 miles starts with 1 step. We think we have taken a few steps, but there is still a long way to go. Thank you.
Thank you very much, Shankar, for this really interesting and inspiring talk. And spot on time as well. We discussed for a pre-talk that over 40 minutes. So this will give us 15 to 20 minutes of a Q&A session. I'll invite, I've already posted on the chat to post questions if you had during the talk itself. And I'm monitoring this at the moment. Yeah, we can open the floor to questions, question and answer session on Shankar's talk, but on the project itself, on Sunbird, or even on other matters relating to EkStep. You may have some questions on that too. So any questions, please. You can come online.
In the chat.
Yeah.
In the chat.
Yeah. So I'll read this out for the benefit of everyone. I know everyone can read, but I'll say it aloud. So this is from Ahmed Hosni. What is the reflection and impact of these efforts on the students and teachers? The question is in 2 parts, by the way. So I'll just put forward the first part and then I'll ask the second part.
Yeah, excellent question. And what we realized was, like with any normal curve, there were some, especially the younger teachers who took to it. There were some, especially those who were already familiar with devices, they took to it. And some of the impacts include, with the energized textbooks, when they saw that textbooks could now talk and speak to them, they realized that even if they don't know how to pronounce that word in that poem, they could go back and listen to it. Our research, what it revealed was a lot of students in India are scared to ask teachers questions. This would allow them to listen to something again and again until they heard. For teachers also, what we realized was, because they knew that the students had access to this, that themselves would go through that, and they realized that they would now have to teach beyond. So the impact on students and teachers was different in different ways, which we had not anticipated. With regards to teacher training, they realized that instead of, in some cases, losing 2 days, instructional days to go to a physical training location and getting trained, the online teacher training they could do in the convenience of their houses. And now that the pandemic is over, different states are thinking of, therefore, how can we have a hybrid training where teachers go through the modules before, and when we meet, we discuss what they have learned and how they intend to use it. So on the assessment of children, it reduced the work of teachers quite a bit. So they were very happy with that. The academic training group suddenly had something to go with on what do we train our teachers, or how do we improve the content in those topics that children are finding it hard. So each of the solutions has had a different impact, but it's too early to say that the impact has resulted in improvement of learning outcomes. But as I said, a whole lot of other things have happened. But the data available with the states is making them question a lot of things. So to give an example, earlier in the first year, 2020, the teacher training was around 45 minutes, single module. But when the data showed that teachers were consuming it in 5 sessions of 9 to 10 minutes each, the second year they reduced the length of each part of a module and made it more user-friendly, because they did not have data before that. And because of the QR codes, every year, states are thinking of improving the quality of content. The initial content was not that great. So then they crowdsourced high quality content from not-profits, which was also through another Sunbird building block. So that's what I mean, that it's evolution that we are seeing. And for us, the value being created is only and only through the usage of these solutions by teachers and children. Thank you.
Thank you very much indeed, Shankar. Does that answer your question, Ahmed?
Yes, thank you.
Okay. So whilst we'll wait for further questions, I have a question, Shankar, if I may. Really interesting to see the amount of work that's been put in by local authorities, I suppose, committees and schools, particularly QR codes reprinting. And it kind of linked to Ahmed's question, especially the second part as I read it, to what extent the devoted efforts covered a large scale of students and teachers from several areas. So I'm interested in finding out, how long did it take to convert a printed book from without the QR code to QR codes? And since this was sponsored by the state, how much work was involved in, say, for example, the moderation of it, linking it to the curriculum so that you can have technology adoption and use by all these areas, considering the different languages, as you said, between state to state?
Yes, so on average, it was 3 to 6 months based on how developed the state was. Because the state had to first, after they made the decision, they had to consult the printers. And what we did as part of the Diksha PMU was create these onboarding packages and guidelines. Which told them exactly what to do. But every state had to figure out for itself the kind of content it had. Those states who were not very confident, the first year they started with only 1 grade and maybe 2 subjects, like Rajasthan, maths and science. They said, we want to get a taste of this. There are some other states like Maharashtra. Both of these are very large states, the size of European countries. Maharashtra was confident enough that in the first year they went with all 12 grades and all subjects. So it depended upon state to state, but it took each state around 2 years to get the hang of this, which means 2 cycles of printing, 2 cycles of connecting QR codes. What they also realized was, unlike a textbook which once printed is gone, since the QR code has a unique number that's a pointer to digital content, they could always change digital content on the back end. So they could release the textbooks, or they could send the textbooks for printing, which happens 6 months before the school starts, and then in parallel prepare the digital content. So every state figured out its own mechanism, and the government of India convened multiple fora where the states could share each other's experiences and learn of each other.
Thank you. Thank you. This is, can I just ask particularly in terms of uptake and adoption, did it tended to be more the urban areas that had more of an uptake for ease of access, I suppose, and telecoms infrastructure than compared, say, to remote villages? When I say remote, I don't mean remote up in high mountains, but more kind of even remote villages on the flatlands in India.
Yeah, excellent question. Now, as I said, with the QR codes and some of those technologies, the data available was on the device-wise usage. So what was encouraged was, if a teacher is in a deep rural area, and if she had a device, she could go to the nearest internet point, download the content of the entire textbook, and then come back and access the content on her phone. Obviously, nobody else in the village has a device. But what she does is, in some states, she plays some of the content, let's say poems, etc., from her phone. In some cases, she now has learned what kind of examples could be used, and she uses the chalk and talk method. In some cases, the states have provided a projector. In other states, a smart television. In some states, they even provided tablets to children at the rate of a tablet for every 3 or 4 child. But what you said is a problem that every state solved in its own context. I won't say solved, is solving. But what was important was it was not restricted to availability of connectivity or devices. Because the way the technology is designed, you download it, or if you have a laptop, you download it, or some states are figuring out a common laptop, etc. Yeah. Of course, uptake would be more in the urban areas, but it is not that it is only in urban areas.
Yeah.
Actually, there are some questions in the chat.
Sure. Yeah. This nicely leads me to that one particular question in the chat, actually, Maiga, from Curtis. So Curtis writes, technology +1 reminds me of, I'll pronounce this, Krashen's comprehensive input that should be I+1, meaning that the input provided by the teachers should be a bit challenging to students, something beyond their current knowledge. So the question is, does this also apply to technology use, using technology that challenges the students?
I won't say the I+1 is relevant here. It was not so much about challenging the students, but allowing the students or the teachers to go beyond what they could do. But yeah, you could talk of it as a zone of proximal development. It allowed the child to access digital content through a trusted resource. It allowed teachers to convert face-to-face training to online training. It allowed teachers to scan with their phones a physical mark sheet. So I like to think of it as it enhanced the capabilities of the students and the teachers, but through a habit, a routine, a process that was familiar to them. So the I+1 is existing technology, existing routines, just one extra process. So the +1 is more also just a slight increase in effort to their day-to-day routines. As I said, the best technology is that which is invisible. We don't think of things like WhatsApp or Zoom as technology anymore because, well, it is Zoom or it is WhatsApp. It is only when a certain technology reaches that level of comfort are they ready to take the next step, the next leap of technology. That is how we constructed +1.
Thank you.
Okay, thank you very much.
There is another question from Spruha?
Sorry, Phil. To give an example of a design decision we made, technologically, it is not complex for the phone to scan the page in the textbook and realize what is being taught. We know technologically that's not a problem. But by printing a QR code is also a visual signal to the child and teacher to say that, hey, there is some content you can access through this QR code. That visual signal was very important for their day-to-day habit. So we evaluated both and went in for the simpler technology. And of course, we tested both. And we realized that the QR code printed had a greater chance of adoption than, let's say, just scanning a page and then figuring out what content it was. Sorry, Phil, but
No, that's fine. Actually, I wanted to, I don't know if we're allowed to do this, Micah, but I wanted to come back to Curtis and say, it's interesting. Your question is interesting, but I'm of the view as well as to simplify technology as much as possible makes it possible for people to use more and more. So I was interested to hear back from you about when you say, does this also apply to technology use? As in, you're looking sort of for a method to integrate more complexity in the technology used to enable students inherently to learn about the use of technology. Is that what you mean?
No, I was like, yeah. So when we think about integrating technology for learning, most of the time we probably think about how familiar the students are in terms of technology, right? We don't really want to ask students to spend extra time learning how to use the technology, so that it actually impairs, or let's say actually affect the learning time that should be attributed, or that should be assigned to the students. So in a way, I was like, maybe, well, I just got a little bit confused about the +1. Yeah. So if we really use something that we think that is potentially useful for the students, and then that is also at the same time students find themselves comfortable with the technology simply because they have been used to it, right? So I would say that maybe it would be more like an optimal learning context for them. Yeah, so that's my idea.
Yeah, no, that's why I typed there that, for me, the shortest definition of +1 is where someone sees radical benefits through habits that are still practical. So if you have to take a lot of time to learn the new technology,
yeah,
that won't be +1.
Okay.
But in using what is intuitive, suddenly it becomes a radical benefit. So you cannot imagine going back to an earlier life.
The next question is from Spruha, who writes, wonderful talk and kudos on achievements of impactful implementation. I'm curious to know the ongoing research to evaluate the implemented solutions. Another question, I suppose I'll read on. Another question is that part from the efforts towards digitization, does the technology adoption also include the mechanical hands-on experiential aspects as these projects for the schools where screens have not yet reached?
Okay, let me answer the second one. As of now, there is no mechanical hands-on experiential aspect as of now. But those could be additional building blocks where, say, suppose somebody has built a complex project, right? A physical project. A photograph of that could be taken and then graded by some other expert sitting somewhere, especially if it's a skill-based course. So there are a lot of discussions around that, but nothing yet on the ground. On the first one, as I said, the efforts are still ongoing. And right now, the only evaluation of any implemented solution is usage, which means some solutions never got used at scale. And so why bother evaluating? Those that have gotten adopted or getting adopted, those would be evaluated by the respective states, because every state is free to use the kind of research. The research that we do at EkStep is the research before and during to understand what people find valuable about this. but nobody has yet done a final outcome impact assessment. We expect that to happen in the next couple of years.
Does that answer your questions, Pruha?
Yes, thank you, thank you.
Okay. There's actually a further question here from Rabi about students' performance varies on the subject. How do we evaluate the performance of the students in general? But I think, Shankar, to some extent, you have actually answered that question in terms of you are in the process of doing the evaluation, but there's still a bit more work to do in order to reflect back on the evaluation of the use and of the performance, if I'm correct.
Oh, the way I interpreted Rabi's question was, let me attempt answering that. In every subject, there's a set of learning outcomes. So the respective states, as part of their assessment, frame questions to understand whether those learning outcomes have been achieved or not. So there is no one size fits all performance of the student in general kind of evaluation. It is very grade wise, subject wise, board wise. The only general evaluation can be have learning outcomes improved in general across. And that is the research which I said is yet to be done, but the evaluation of the performance of students, some of the states have already started. So what they do is they do a baseline assessment and then do a whole lot of other, whatever they do as a system. And then they do an endline assessment to see if anything has improved. So that kind of work is what has begun. It is subject-wise, learning outcome-wise, and done by the states.
Thank you very much. I'm afraid we're nearly running out of time. We have just under 1 minute left, and as is traditional, so first of all, I'd like to thank Shankar for his talk. Very much appreciate it. I'm sure everyone can join me to thank you as well.